For centuries, humans gazed at birds soaring effortlessly in the sky, longing to experience the freedom of flight. The desire to conquer the heavens, to break free from Earth's embrace, was a dream woven into myths and stories across cultures. Early attempts, often mimicking the flapping wings of birds, proved unsuccessful. It wasn't until the late 19th century that the Wright brothers, through meticulous observation and relentless experimentation, unlocked the secrets of flight. On a blustery December day in 1903, at Kitty Hawk, North Carolina, their creation, the Wright Flyer, took to the air. It was a momentous occasion, marking the birth of powered, controlled flight. This groundbreaking achievement, a mere 12 seconds and 120 feet, forever altered our relationship with the sky. The years that followed witnessed rapid advancements in aviation technology. Planes grew larger, faster, and capable of carrying more weight. What was once a daring feat became a mode of transportation, connecting distant lands and shrinking the world. The dream of flight, once a distant aspiration, had become a reality, ushering in a new era of exploration, connectivity, and boundless possibilities. The ability of an airplane, a machine weighing tons, to take flight and soar through the air seems almost magical. However, this captivating feat is rooted in the fundamental principles of physics, particularly the concept of lift. Lift is the force that opposes gravity, essentially lifting the airplane off the ground and keeping it aloft. This upward force is generated by the wings of the airplane as they cut through the air. The shape of an airplane wing is crucial. It is designed with an airfoil shape which is curved on the upper surface and relatively flat on the lower surface. This unique shape plays a vital role in generating lift. As the airplane moves forward, air flows over and under the wings. Due to the curved upper surface, the air flowing over the wing has to travel a longer distance than the air flowing under the wing. This difference in distance creates a difference in air pressure. The air flowing over the wing moves faster and exerts less pressure, while the air flowing under the wing moves slower and exerts higher pressure. This difference in pressure creates an upward force lift that pushes the wings, and consequently, the airplane, upwards. Understanding lift is fundamental to understanding how airplanes fly. This aerodynamic principle, harnessed through meticulous design and engineering, allows us to navigate the skies. An airplane is much more than just a collection of metal parts. It is a complex and meticulously engineered marvel, each component playing a crucial role in ensuring a safe and successful flight. At the heart of the aircraft lies the fuselage, the main body of the plane, housing passengers, crew, and cargo. Extending outward from the fuselage are the wings, the aerodynamic marvels responsible for generating lift. Attached to the wings are the engines, the powerhouses that propel the airplane forward, creating the airflow needed for lift. At the rear of the plane is the tail section, consisting of the vertical stabilizer and horizontal stabilizers. These components provide stability and control, helping the airplane maintain its direction and altitude. The rudder, a movable part of the vertical stabilizer, controls yaw, left and right movement, while the elevators, located on the horizontal stabilizer, control pitch, up and down movement. The ailerons, located on the trailing edge of the wings, control roll, the aircraft's movement around its longitudinal axis. Together, these control surfaces allow pilots to maneuver the airplane with precision, guiding it through the air. Understanding the basic anatomy of an airplane provides a glimpse into the complexity and ingenuity of these incredible flying machines. While the wings are responsible for generating lift, it is the engines that provide the necessary thrust to propel the airplane forward, creating the airflow needed for lift. These powerful engines are a marvel of engineering, converting fuel into thrust, propelling the aircraft through the air. Modern airplanes typically use jet engines or turboprop engines. Jet engines, commonly found on larger aircraft, work by sucking in air, compressing it, mixing it with fuel, and igniting the mixture. The resulting hot gases are expelled at high speed, creating thrust that pushes the airplane forward. Turboprop engines, often found on smaller aircraft, work on a similar principle, but instead of using the exhaust gases directly for thrust, they use them to spin a propeller. This spinning propeller, much like a giant fan, pulls the airplane forward. The power of an airplane engine is measured in thrust, which is the force that propels the airplane forward. The greater the thrust, the faster the airplane can fly, and the heavier the load it can carry. The engines are a critical component of an airplane, providing the driving force that enables us to take to the skies. Section 5. From runways to the clouds. The journey of a flight. A typical flight is a carefully orchestrated sequence of events beginning with taxiing from the gate to the runway. As the airplane positions itself on the runway, the engines roar to life, spooling up to provide the necessary thrust. With clearance from air traffic control, the pilot releases the brakes, and the airplane accelerates down the runway, gaining speed rapidly. As the aircraft reaches a critical speed, enough airflow is generated over the wings to produce sufficient lift to overcome the force of gravity. The nose of the aircraft lifts, and the plane climbs gracefully into the air, leaving the ground behind. The aircraft ascends through the lower atmosphere, climbing to its cruising altitude, typically between 30,000 to 40,000 feet. At cruising altitude, the aircraft flies at a relatively constant speed and altitude, covering vast distances efficiently. As the flight progresses, the pilots constantly communicate with air traffic control, receiving instructions and updates on weather conditions. Section 6. Aviation, connecting the world. Airplanes have revolutionized the way we travel and experience the world. They have shrunk distances, connecting continents and cultures in ways unimaginable just a century ago. International travel, once a luxury reserved for the elite, has become more accessible, allowing people from all walks of life to explore distant lands, experience different cultures, and foster global understanding. The impact of aviation extends far beyond tourism. It plays a vital role in global trade and commerce, facilitating the movement of goods and services across borders. Businesses can now operate on an international scale, transporting products and raw materials efficiently and cost-effectively. The speed and efficiency of air travel have also transformed the way we respond to emergencies and crises. Relief organizations rely heavily on airplanes to deliver humanitarian aid to disaster-stricken areas, providing essential supplies, medical assistance, and logistical support. Section 7. Beyond passenger flights. The diverse roles of airplanes. While passenger travel is perhaps the most visible aspect of aviation, airplanes play a multitude of other critical roles in our modern world. They are versatile tools, adapted for a wide range of applications beyond transporting people from one place to another. Cargo planes, specifically designed to carry goods instead of passengers, play a vital role in the global supply chain, transporting everything from electronics and clothing to perishable goods and pharmaceuticals. This efficient movement of goods is essential for international trade and economic growth. In agriculture, crop dusters are used to spray fertilizers, pesticides and herbicides over vast fields, increasing crop yields and protecting them from pests and diseases. Their maneuverability and precision make them invaluable tools in modern agriculture. Airplanes are also used extensively in firefighting, particularly in combating wildfires. Equipped with large water tanks or fire retardant, these aircraft can drop their payloads with precision, helping to contain and extinguish fires that threaten lives, property, and natural resources. Section 8. Flying into the future. Innovations in aviation. The world of aviation is constantly evolving, with engineers and innovators pushing the boundaries of what's possible in aircraft design and technology. New materials, propulsion systems, and digital technologies are shaping the future of flight, promising even greater efficiency, sustainability, and passenger comfort. One of the most exciting developments is the pursuit of electric and hybrid electric aircraft. These technologies aim to reduce aviation's environmental footprint by decreasing reliance on fossil fuels and minimizing greenhouse gas emissions. Advancements in artificial intelligence and automation are also transforming the cockpit. While pilots will always remain at the heart of aviation, these technologies are enhancing safety, improving efficiency, and reducing pilot workload. From supersonic aircraft that could potentially cut travel times in half to autonomous air taxis that promise to revolutionize urban mobility, the future of aviation is brimming with exciting possibilities. Section 9. The enduring magic of flight. Despite the technological advancements and the ubiquity of air travel, the magic of flight remains undiminished. The ability to take to the skies, to soar above the clouds, and witness the world from a different perspective continues to inspire awe and wonder. Whether it's the thrill of takeoff, The serene beauty of cruising altitude, or the gentle touchdown after a long journey, flying offers a unique and unforgettable experience. It's a testament to human ingenuity, a symbol of our boundless curiosity and our enduring desire to explore the unknown. As we look to the future, the quest for innovation in aviation continues, driven by the desire to fly higher, farther, and more sustainably. And as we push the boundaries of what's possible, the enduring magic of flight will undoubtedly continue to captivate generations to come.